Hello, students, and welcome to Big Ideas, Chapter 2. Today we're starting Lesson 2.1 on rational numbers. Follow along with me in your red textbook beginning on page 46. Our key idea for this lesson can be found on page 44. We're going to review. The definition of rational number is a number that can be written as a fraction, a over b, where a and b are integers and b cannot be equal to 0. So if you look over here at this diagram, you'll see whole numbers are in the center. Whole numbers are any positive whole number that cannot be a fraction, such as 0 and positive 4. Integers are the realm of positive and negative numbers. So it includes whole numbers, which are positive, but it also includes the negative numbers, like negative 10 and negative 2. In the outside square, you see rational numbers. And rational numbers are decimals, fractions, and then we also see mixed numbers. And then we also see these here are repeating decimals, and they can be positive or negative as well. So I'd like you to write this down. A rational number is a number that can be written as the ratio or fraction of two integers. And I'm going to give you some examples I'd like to copy down as well. For example, 3 over 1, which is 3, is a rational number. It's a fraction. The number negative 2 can be written as negative 2 over 1. It's a fraction. Point 5 can be written as 5/10, which reduces to 1/2. That's a fraction. Negative 2/3 is also a rational number. So any number that can be written as a ratio of any two integers is a rational number. Now, rational numbers can also be decimals, which we'll talk about in just a moment. Pause if you need more time to finish copying down the definition and these examples. On page 46, now we're looking more into the different types of decimals. There are two types. There's terminating decimals and repeating. A terminating decimal is a decimal that ends. If you speak Spanish, terminar means to end. So think about a decimal that stops. For example, 0.25 is a terminating decimal. 3.875 is terminating. It stops. 2.4, negative 3.7. These are all terminating decimals, and there's a clear end. However, repeating decimals are decimals that have a pattern or that repeat. For example, you might see this number 0.3333. Instead of writing out those threes that continue on forever, you would rewrite it simply as 0.3 with a bar above the 3. You put the bar above the digit that repeats. Another example would be if you had 0.161616. The part that's repeating is the 1 and the 6, so you would rewrite it as 0.16 with a bar above the 1 and the 6. These are repeating decimals, and they go on forever. So remember to include that bar above the digits that repeat. In example 1, we have to write the rational numbers as decimals, and this is on page 46. So we need to write negative 2 and 1/4 as a decimal. There's two ways you can do this. The first way is you can change the mixed number into an improper fraction. So you multiply the denominator times the whole number. 4 times 2 is 8, plus 1 more is 9 over 4. And because it's negative, you want to keep the negative sign in front of it. Then you would just go on and divide. So 4 goes into 9 twice. Subtract 8, you have 1 left over. And since we have 1 left over, we need to add a decimal point and bring down a 0. 4 goes into 8 2 times as well. Subtract 8 and you get 2 left over. Add another 0 and bring it down. 4 goes into 20 5 times. And when you subtract 20, you get 0 left over. So this is a terminating decimal of 2.25. Don't forget it is negative. So our answer will be negative 2.25. Let me rewrite this. There we go. So negative 2.25 is a terminating decimal. Another way to do this, if you look, negative 2 and 1/4, the 2 is a whole number, so I already know it's going to be negative 2. I know 1/4 is equivalent to 0.25. I just memorized that fraction as a decimal. So when I put it together, negative 2 is the whole number. The fraction is 0.25. So negative 2.25 is a quick way to check. Now in B, 5 over 11 is a little bit different. So we put the top number in the box, if you will. So 11 goes into 5 0 times. 11 is larger than 5, it doesn't work. So I add a decimal point and put a 0 after that. 11 can go into 54 times. When I subtract 44, I get 6 left over, so keep going. Add a 0, bring it down. 11 goes into 65 times. Subtract 55, and you get 5 left over. Add a 0, bring it down. 11 goes into 54 times. 11 times 4 is 44. When I subtract, I get 6 left over again. I'm going to add a 0, bring it down. 11 goes into 65 times. When I subtract 55, I get 5 left over. And you'll notice this pattern, 0.4545. It's going to keep going. Instead of continuing on and on forever, we simply rewrite this repeating decimal as 0.45 with a bar above the 4 and the 5. And that shows the 4 and the 5 repeat. At this time, I would like you to complete on your own on page 46. I want you to write the rational number as a decimal. Remember, if it has a negative sign, to make your answer negative, and to show all your work. There are no calculators for this section, so you need to show the work of division by hand. Example 2 is writing a decimal as a fraction, and this is on page 47. Write negative 0.26 as a fraction in simplest form. Now, for this one, you look at the decimal point, and it goes 2 places after the decimal. The first place, the 2 is in the tenths place, and the 6 is in the hundredths place. So when I rewrite this, I rewrite it as negative 26 over 100. Now, I look to see if I can simplify it because it says simplest form here. Oops. And when I write it in simplest form, I need to reduce. I automatically see 6 and 0 are even, so I'm just going to start by dividing by 2. That gives me negative 13 over 50. And since 13 is prime, it cannot be reduced any further. So my answer is negative 13 over 50. A bonus example that I'd like to include is negative 4.5, and we need to write that as a fraction as well. Now, negative 4 means you have 4 whole numbers, and then 5.5 is 5 tenths. So I'm going to rewrite this as negative 4 and 5 tenths. From here, all I need to do is reduce the fraction. I see 5 goes into both 5 and 10. So when I reduce it, it's negative 4 and reduce the fraction, and that becomes 1/2. So negative 4 1/2. At this time, I would like you to complete on your own on page 47, numbers 5 through 8. You're writing these decimals as a fraction or a mixed number, and remember to put it in simplest form by reducing. Example 3 is ordering rational numbers, and the table here shows the elevations of 4 sea creatures relative to sea level. Remember, sea level is 0. Which of these sea creatures are deeper than the whale? Now, we have an anglerfish at negative 13 over 10, and I'm going to change the elevation from fractions into decimals. Negative 13 over 10, if you divide it, 10 goes into 13 once, with 3 left over, add a decimal point. So I get negative 1.3 kilometers. Negative 2 and 1/5, I'm going to divide 1/5. 1 goes in top, 5 goes outside. 5 cannot go into 1, but 5 can go into 10 2 times. And it goes evenly, so I stop. So this is negative 2.2. Now 2 over 11, I'm going to work this one out. 11 goes into 2 0 times, but it can go into 20 once. Subtract 11 and you get 9 left over. 11 goes into 98 times. Subtract 88, you get 2 left over. Keep going. Add a 0. 11 goes into 20 once. Subtract 11, you get 9. And I'm starting to notice a repeating pattern here, and I think this is going to go on forever. So I'm going to rewrite this as negative 0.18 with a bar above 1 and 8 to show that it repeats. And the last decimal is actually done for us. So this stays negative 0.8. Now it wants to know which ones are deeper than the whale. So the whale is at negative 0.8. And if you look at this number line, I sectioned it off into quarters. So we have 0 in the center, right there. The whale is negative, so I go left. And 0.75 would be here, so it's going to be just past 0.75, and this is the whale. Now I'm going to graph all the other elevations as well. Negative 0.18 repeating is going to be about right there, and that's the shark. So the shark is actually closer to sea level. It's not deeper. We want to see what animals are deeper than the whale. Now look at the squid. The squid lives at negative 2.2. So 2.25 is here, so this is going to be the squid at negative 2.2. And then the anglerfish is at negative 1.3, which is just past 1.25. And that's, I'm just going to call him angler for short. So which creatures are deeper than the whale? Well, if the whale is at negative 0.8, that means the anglerfish at negative 1.3 kilometers, or 13 over 10. And the squid, which is at negative 2 and 1/5 kilometers, are deeper than the whale. So it wants an explanation, so I need to write it out in a sentence, just like I did, and I need to show why. The whale is only at negative 0.8 kilometers. So as you travel more left, you're going deeper, negative. Now, for question number 9, I want you to explain what if the elevation of the dolphin is negative 1/10 of a kilometer? Which of the sea creatures in example 3 are deeper than the dolphin? So add the dolphin's depth to the number line and see which creatures are further negative. Be able to explain your thinking in class tomorrow. And your exit ticket for this video is to write negative 5/6 as a decimal and write negative 0.56 as a fraction. I want you to compare these two and tell me, are they the same value or are they different? In class tomorrow, make sure you bring your charged Chromebook as well as your record and practice journal. Have a great evening, and I'll see you then. Bye-bye.